Hey guys, sorry about my finger there. So today we are going to be learning about chapter 7.5, which is solving rational equations. Now this is a little different than what you've been doing the last two classes, because if you remember the last two classes, your answer hasn't been x equals, right? It's been like, I don't know, x plus 1 over x minus 2, right? But our goal now is to actually solve an equation. So these are equations, they've got equal to signs. So our goal is going to be a little bit different. It's going to be to find out what x is. So when we solve a rational equation, both these situations, we have one fraction equal to another fraction. Right, so in this situation, we have a really cool strategy that might remind you of something you learned in, I don't know, 6th grade or 7th grade, and that is to cross multiply. So we're going to be able to cross multiply when we have this simple situation of a fraction equal to a fraction. So this might look familiar to you guys. I'm going to multiply these on the diagonal here. And then I'm going to set them equal to each other. So I'm going to do 3 times 4x plus 5 equals 9 times x plus 1. Okay, now we're just going to solve the equation. So that's 12x plus 15 equals 9x plus 9. Right, and then if we solve this, we get 3x equals negative 6 and x equals negative 2. Now here's the thing, right? Remember when we were doing rational functions, guys? I mean, not rational functions, square roots? We always needed to make sure, and when we were also graphing rational functions, we always had to check the solution to make sure there is no 0 in the denominator. So we must check solutions. We must check solutions to make sure there is no denominator equal to 0. Okay, so I'm just going to write this because it's very important. I can spell denominator. Okay, so we can't have a 0 in the denominator. So to check x equals negative 2, my main purpose is to make sure the denominator isn't 0. So I'm going to go plug negative 2 back in here. So the first thing is, yay, it's not 0. Neither of those are 0. Now, if I want to be super thorough, I could go further and say, let's see if I actually got the right answer. So this is 3 over negative 1, and this is 9 over negative 3. So yeah, look at that, I got it right. So always check, even though it's annoying and it can be sometimes hard to remember to do it, it's extremely important to check. Now, of course, this time you think, well, so what, it worked, but we're going to get to ones where one answer is not going to work. Sometimes both don't work. Okay, let's try the next one. So the next one, again, we have one fraction equal to one fraction. So we get to use our cool cross multiply. So this one's a little more complicated because I'm going to have to FOIL. So I've got x plus 3 times x minus 2 equals x plus 1 times x minus 5. And remember, here I need to FOIL both of these. So if I FOIL, I get x squared plus 3x minus 2x minus 6. And on this side I get x squared minus 5x plus x minus 5. Now I'm going to neaten this up a little before I start moving across the equation. So I have x squared minus 4x minus 5. Now this one looks initially like it's really awful, but look, do you guys see this? The x squareds are out. So all I have, again, is a simple equation. Simple linear equation. X minus 6 equals negative 4x minus 5. Okay, so that's going to give me, add the 4x, and add the 6. So I get 5x equals 1, and x is 1/5. So again, we have to make sure that we check. We're going to check x equals 1/5. So I'll do that over here. Let's check x equals 1/5. So I'm going to go back to my equation. And I want to make sure that I end up with not zeros here. Right? So that's what I'm really concerned with. But if I really want to, I could figure out whether I actually did this right. Right? So that's 16/5. This is, right, if I multiply it by 5, that's 25. This is negative 24/5. Right? This is 6/5. And this is negative 9/5. Right? So let's see here. Oh, look, we've got 16 over negative 24, which does in fact equal 6 over 9. They're both negative 2/3. So not only are we okay with our answer, we also got it right. Even better. So in these situations, we have one fraction equal to another fraction. But of course, we're going to spice this up a little, as we know. So notice, guys, on example 3, it wouldn't work to cross multiply because I don't have these fractions all in one fraction. So I have two choices. I could combine these by getting a common denominator like you learned about in 7.4. Or I think an easier process is to use what we call a fraction buster. Okay, and you might have heard about this in your Algebra 1 class. A fraction buster is kind of like a dust buster. Like dust busters just come and take dirt off the floor, right? Well, we're going to sweep denominators away here. So first thing we want to do is we want to find the least common multiple of the denominators. So that's the first thing we want to do. So that's our first step. Once we find the least common multiple of the denominators, we are then going to multiply every fraction so let's call this the LCM. We're going to multiply all the fractions by the LCM over 1. Now you may wonder, why is that going to help? That's just going to make it look worse. But I'm going to show you guys why it works. So let's look at these three denominators here. And let's figure out what the least common multiple is. So the common word means that I have to be able to multiply all of these to get the other. So I want to include the x and the 4. So my least common multiple here is 4x. Okay, so when you do these problems, it is a little irritating, but I'm going to recommend something. We are going to take all of these problems, or all of these fractions, and multiply them by 4x over 1. Okay, so my suggestion, even though it's a little annoying, is to recopy the problem. And right next to that, what every single fraction, you're going to multiply by 4x over 1. So like I said, it is a little annoying. I'm going to do in blue. In black, it's going to be the problem just recopied. But notice what I'm going to do here is I'm going to multiply everything by our least common multiple over 1. notice I'm just writing it to the left of every single fraction. Okay. Now, you may say, oh wow, Miss Brindley, that makes everything, not only does it not help, it just makes it look so ugly. However, we're going to have this beauty of math moment here right now. I'm going to put a little box around all of the little multiplication problems I created by multiplying everything by 4x over 1. And now is the best part. Because what I just did is I just created opportunities to cancel stuff. So like you learned in 7.3, when I have multiplication like this, I can reduce anything on the top with anything on the bottom. So watch what's going to happen to the denominator here. Goodbye, denominator. So now all I have is 4 times 5. And 4 times 5 is 20. Do you guys see how this just disappeared? The denominator just disappeared. Okay, that is amazing. Okay? And if we have our LCM right, all of the denominators should disappear. That's the purpose of this. So notice here I've got, okay, what's on the top and the bottom? Well, 4 is on the top and the bottom. So now all I have is x times 7. So that gives me 7x. And then on this side, sorry, I have to make sure I can see that's multiplication. On this side, I can cross out the x. And notice, I just have 4 times negative 9, which is negative 36. Guys, presto, all of the denominators are gone. And now I have myself just a simple equation that I can solve. Right? And that gives me 7x equals negative 56, and x equals negative 8. Okay, and as we know, we got to check. Make sure we have 0 denominators here. So let's check, we'll do it over here. Check, x equals negative 8. So I'm going to say 5 over negative 8 plus 7 over 4. Does that equal negative 9 over negative 8? Well, we're really happy none of these are 0. But if we want to be super thorough, we could just make sure we got this right. And we did, look. Is that true? Well, if I multiply this by 2 and get a common denominator, I'll have negative 5 over 8. Oh wait, oops. This is negative 8. Let's mess that up. Yeah, negative 5 over 8 minus, 7 over 4. What am I doing? Plus 7 over 4, so which is plus 14 over 8 equals negative 9 over 8. Negative 9 over negative 8. Okay, that's perfect. So I get 9 over 8 equals 9 over 8. Sorry, had a moment of messed upness there. Okay, so multiplying everything by the least common multiple over 1, right? That's what we're going to be doing. So the second one, finding the least common multiple is a little bit more annoying. First of all, they didn't give me a denominator here, so I know if it's 1, it's just 1 over 1. So again, my least common multiple has to include every one of these pieces here. So I have to include the x and the x minus 5. Now I don't have to worry about the 1, right? So what I'm going to do is I'm going to take all of these fractions, including the 1 over 1, and I'm going to multiply them by x minus 5 over 1. So let's see what that looks like. X times x minus 5 over 1. And again, I'm going to recopy, even though it's a little annoying. It really does help to do this. It's worth the extra minute because it's going to reduce the chance of an error. So notice in black is the original equation, and in blue is the multiplying everything by x minus 5. And again, I'm going to use my little green, and I'm going to put little rectangles around my new multiplication problems I have here. And now's the fun part. Now I'm going to get to cancel stuff. Well, here I can't cancel anything because the denominator is already a 1. So I'm stuck with x times x minus 5 here. Now, I'm going to do, okay, here is the fun. This one's fun. I get to cancel out the x minus 5s. So all I'm left with on the top is x times 8. So this is 8x. And then we have our equals. And here we get to cancel out an x. So we're left with 3 times x minus 5. Okay, and this one's a little different because look, we've got ourselves a quadratic, guys. So this is a little different. So let's distribute. So I have x squared minus 5x minus 8x equals, and I'm going to distribute here, 3x minus 15. Okay, guys, remember with the quadratic, we're getting everything on one side, and then we're going to do a diamond. Right, so we've got that. So I'm going to subtract the 3x and add the 15. And I'm going to end up with x squared minus 16x plus 15 equals 0. So I'm going to take for granted you guys know how to do the diamond. That's x minus 15 times x minus 1. So that means we're going to have two answers to check. We're going to be checking x equals 15 and x equals 1. So before I put my little box around them, I'm going to check. So let's check x equals 15. I'm going to go back to the original problem. So here's my original problem right here. I'm going to do 1 over 1 minus 8 over 15 minus 5 equals 3 over 15. So that is 1 over 1 minus 8 over 10. Does that equal 3 over 15? Yep, it does. That's the first one. So we're good with that. Now let's check x equals 1. 1 over 1 minus 8 over 1 minus 5. Does that equal 3 over 1? I think it does. 1 minus 8 over negative 4. Does that equal 3? And yes, it does. So we're happy with both our answers here. And you may be wondering, Miss Brindley, why do we have to check? All of them work. But the best one is for last. And you will see what it means to not work. So here, just to give you guys another view, that's how we're going to use a fraction buster. We use a fraction buster when we don't have a simple one fraction equal to another fraction. So these, the common denominator, right, we didn't have to really, all we had to do was really look at the denominators, but sometimes the common denominator or the common multiple, common denominator and common multiple are the same. I use the word multiple because I don't want you guys to find the common denominator here. The common multiple, I want you to actually multiply by the common multiple. Here, the least common multiple, now that word least common multiple, there's a little bit of disguise going on in this last one. Because it looks like, oh no, I have to account for all three of these. They're all different. So do I really have to multiply everything times x minus 3, x squared minus 9, and x plus 3? Well, I would until I realize that this is actually factorable. So I might have some overlap here. So this factors to x plus 3, x minus 3. So when I think of my least common multiple here, guys, I actually already have some shared here. There's some overlap. So if I look at what's unique here, the only two unique factors are x plus 3 and x minus 3. So my least common multiple is going to be x plus 3, x minus 3. So I always want to factor the denominator if I can. Okay guys, tedious part, you ready? I'm going to multiply everything by x plus 3, x minus 3 over 1. And then I'm going to recopy this. 6 over x minus 3 equals, again, a little tedious but worth it, x plus 3, x minus 3. And I got 8x squared, and I'm going to say, okay, well I already know this is x plus 3, x minus 3. I figured that out above. And then I've got minus, alright, gotta be consistent here. I got minus, and then I've got x plus 3, x minus 3 over 1. Times 8x squared. Sorry, times 4x over x plus 3, sorry. Okay, so this one's kind of a much more annoying. But again, I'm going to put rectangles around these little multiplication problems that I created. And to be honest, my favorite part is the reducing part. This isn't really a rectangle, sorry, a little shape here. So let's see what we can get rid of over here in our first little group. Well, I can get rid of the x minus 3's. So those are out. So what I'm left with here is 6 times x plus 3. All right, and then I got my equals. Ooh, this is great. Look, boom, 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 boom. All I have here is 8x squared. And then I got a minus. And then I'm going to just draw a little arrow here. And I got 8x squared minus, and then what can I get rid of here? Well, I can get rid of the x plus 3. So that leaves me with 4x times x minus 3. Okay, so now I don't have any more denominators. I do have myself kind of a bear here, because I can see it's going to be a quadratic, right? So let's start. Let's start solving. I'm going to distribute that and get 6x plus 18. And here I've got 8x squared. Okay, now be careful here, guys. I'm distributing a negative 4x. So that's going to give me minus 4x squared plus 12x. Okay, so we've got some like terms here. We got these guys. So I've got 6x plus 18 equals 4x squared plus 12x. And now I know I got myself a quadratic, so I've got to get everything to one side and then do a diamond. Right? So I'm going to end up with, I'll do it right here, 0 equals 4x squared plus 6x minus 18. All right, that doesn't look super fun, diamond with those big numbers. So I'm going to notice, oh look, I can pare these down a little. I can't get them completely, I can't get this to be a 1, but I could notice that everything's divisible by 2. So that's going to make my life a little easier. So this time I am going to do the diamond. Right, so I want to find my diamond, I want to find two numbers that multiply to negative 18 and add to 3. And those would be 6 and negative 3. But remember, that's not a 1, so I can't just go x plus 6, x minus 3. I wish, but I can't. So I have to do some form, either grouping or a box, however you want to do it. So I have to recognize when I need to do that. And it's when this value a in front of the x squared is not 1. So here I need to find my greatest common factor in the first group, which is 2x. And my greatest common factor in the negative, or in the second group, which is minus 3. So I have to remember that's actually going to be an x plus 3. And I can always redistribute to check. So remember, my factors are going to be x plus 3, which is common to both of them, and then 2x minus 3. So I'm going to end up with two answers here, guys. And my two answers are going to be x equals negative 3 and x equals 1.5, or 3/2, however you want to write it. Okay, guys, this is the big moment. We are now going to check these. Let's check x equals negative 3. So that means I'm going to go back and plug it in. 6 over negative 3 minus 3 equals, here it is, guys, big moment, 8 times negative 3 squared over negative 3 squared minus 9. Oops! The denominator is 0. So guess what, guys? Sorry, negative 3. I don't even need to go any further. Once it happens, it's out. Right? I would also have a problem over here if I put negative 3, but once I see it once, goodbye. So we're going to hope for 1.5. So let's check that out. 6 over 1.5 minus 3 equals 8 times 1.5 squared over 1.5 squared minus 9 equals 4 times 1.5 over 1.5 plus 3. Okay, guys, here's where maybe I don't want to go the whole way to check this. All what I'm really looking for is, are any of these 0? If they're not, I'm going to say, all right, and we're going to be happy with 1.5 or 3/2. Now, I could actually have gone through and simplified all that, but I think you guys get the idea. Okay, guys, that's it for chapter 7.5. I'll see you soon.